Hello, and welcome to a TimelinePI demonstration based around City Service Request. This demo, as well as others, can be found at online.timelinepi.com. Before we start, I'd like to define the main thing we're dealing with, a timeline. A timeline is simply the history of a process instance. This could be a sales order, an invoice, an insurance claim, or in this case, a city service request. Aside from that, TimelinePI is not a business intelligence tool. BI tools use a process instance's current attributes for its analysis, whereas this tool brings together its timeline and analyzes its history. Today, we'll be going through the creation of this project from start to finish, so let's get started. This example is based around city and government services, more specifically the process of service request in a local city or county government. To begin, we will need to upload a CSV file to the timeline tool. I have one here that's pre-prepared. There are just three fields which are required. First, want a time field. This is simply going to tell you when an event happened. Next, an ID field. This allows you to join together all of the events in a given process instance into the same context. You can think of this as a customer, a patient ID, a claim number, or an invoice ID, or any other type of unique identifier which signifies what we are looking to measure. Lastly, you'll need a field which tells us what happened at that step. This is the event that occurred. This will tell us the work that was completed. For example, a new sales quote was issued, a claim was submitted, a patient arrived, or work was completed. Those are the only three required fields we'll need. And lastly, we can bring in additional fields. These may be considered as dimensions and ways to further to slice and dice and break down the data. We'll use fields like department, facility number, or even employee. And it's worth mentioning that these timelines can be assembled from multiple files corresponding to different systems of record, so different events come from different sources. As long as they all have the same object identifier, we will be able to connect them together. So now that we've mapped some columns in a file, we now simply hit load and allow the tool to begin reconstructing the process based on these events. I've already loaded the data for this demo, so we won't waste time doing that. But if I had loaded the data, it would take about a minute to a minute and a half to load what we have, which is about 300,000 events related to these encounters. In that time, the tool will reverse engineer the process, build out all of the models, and create multiple forms of analysis. Once we've uploaded our data, we're then presented with the overview page. This includes quite a few metrics which are going to give us a better understanding about our project and the data we've uploaded. The first thing I want to bring your attention to is these roughly 300,000 events that have been loaded and have been mapped into approximately 28,916 timelines, or in this case, city service request. Here we've pulled 16 different types of events from that data. If I pop these up, we can see them listed. These can be sorted by occurrence, how many timelines they occur on. The other thing that I want to mention is that I've assigned a few icons to these as opposed to the default circle with a gray number. These can simply be a color, you can upload your own icon, whatever is going to make it stand out for you. So that's all we've done, so everything else I show you from here on is automatically done by the technology. There are some other metrics which have automatically been calculated from the data, as well as the many different analysis apps which we can examine further over here to the right. These metrics include the number of timelines in the current set and its percent to all the timelines, which will be changing as we go through the analysis. The total and average duration of the process, the number of events per timeline, how many of them are unique. Remember that events can be duplicated or done multiple times in one encounter. We have time gaps where work is not being completed, and also the distribution of the first event to the last event. Essentially, which events most commonly both start and finish our processes. From here, let's move to the timelines view to take a look at the actual paths which the tool has generated. Each of the different lines with the circles on them represents a different encounter, and each circle represents an event or a step in the process. The length of each timeline is proportionate to the elapsed time, so of course there are some that are longer than others, and this includes the gaps between the steps where nothing has happened. So we'll start to see clear examples where bottlenecks may be occurring, where our process efficiency can be improved. Clicking on any one of them gives me much more detail on what happened and in what order and what time. This screen here is showing me details to a specific timeline number or service request number. The column all the way to the left is a superset of all the events which occurred within that specific request. We'd see when a request came in, when work got started. The additional comment to the right, the tool automatically figured out by analyzing the specific patterns in the data as to which things that were most commonly done together were as mutually exclusive steps. In other words, it automatically detected those which are done as sub-processes or parallel processes and has grouped them out together. This is very much a micro view of the process as opposed to the main timeline screen, which at first is a macro view. But the granularity we have here can be really useful if we are looking to uncover the root cause of a compliance problem or a workflow inefficiency. No longer do we need to physically walk around with a clipboard and stopwatch and try to spot what is very often a needle in a haystack. The data in this analysis you have here tells the whole story about this service request, and at the very least can give you clues as to where the problem lies. So if you are thinking about loading up data from multiple systems, we are essentially pulling together the composite life cycle of a service request, from receiving the request to completing the work to fix the problem, regardless of the system of record which is responsible for recording these events. The timeline tool can solve them. The engine itself doesn't know anything about the industry the data is relevant to. It could just as easily have been doing this with insurance, shipping, sales, logistics, or invoice data. It's totally agnostic to the industry. The idea is to give users a much better understanding of what's going on in the business process, no matter what type of vertical is being supported. So again, back at the timeline view, we're greeted with all these different metrics at the top of our page that can show us and demonstrate to us the different things that are happening with our timelines, how long they're taking, how many events are within our timelines, the count of unique events, the average gaps, the first event and the last event, and these are all in according to the current view. So as we run functions and queries and different searches and break down the data, these will all change along with that. We've seen that there's a huge amount of variability in this process, and having looked through this data, I can tell you that there are no two timelines which are exactly the same. So you might wonder if there's some sort of way to map a process diagram that would explain generally how things are working. This is a question that most managers and business users struggle to answer with their existing technology, and is a big reason why most people can't tell you with a high amount of confidence exactly how their processes are being executed. And that leads us into our path analysis tool. Lean, Six Sigma, and process owners would really like this type of view of the data. The tool is showing you exactly how the process was completed, with the most followed paths here to the left. This clearly exposes when steps have been skipped over, done repeatedly, or totally out of order, with the most common path highlighted for us. The tool has suggested these steps along the left, but we can make changes to this at any time. As you add and remove the steps in the process, you'll see it constantly recalculating the percentage of processes along the top, which have gone one way versus the other. The ones in these leftmost columns probably shouldn't come as much surprise because they are the most commonly followed process paths. But scrolling to the right, we can see more and more unusual or obscure behaviors where things are jumping around or skipping steps. Maybe we spot something that is an issue that should never happen, and I can apply that as a filter. And when I do, I'm now shown only the encounters which have followed that path. Remember, it doesn't mean that every single event in every timeline is exactly identical here. It means that each instance contains specific milestones that we care about, and shows exactly how they've been executed. The goal here is to promote continuous improvement. Filtering of the data will become a theme here, as you see as we go. We start with a large data set and begin to whittle it down to more manageable sizes. In certain cases, we will build in conditions or sometimes let the tool do an analysis on its own to try and uncover weird or wonderful things that are occurring with the data. So now I want to begin further breaking down and analyzing the data, thinking like a business analyst would. Perhaps I want to do dimensional searches or queries. I'm going to start looking at a time interval lookup. And one of the things that are really important for this set of data is that these are service requests. So we want to identify when issues are being reported and how long it's taking for work to be completed. So for a city request such as a pothole or a street light that's out, you typically want those things to be fixed under 30 days. So it looks good at this current view. It looks like on average the problems are being fixed at 25 days, 8 hours. However, we selected our issue reported. We selected work completed here. We've added those as our events in our time interval. But what we didn't identify was here if multiple. So we don't want to look at the first time the work was completed. Let's look at the last time. And then what we start seeing is that, well, these problems are actually being completed for the second time, where the work is actually finally complete at 30 days, which is really just right at that grasp of where we want to be. So we can break it down to 1 month, begin to analyze and break down the data, apply a filter, and start seeing just the timelines that are over 30 days. And you can see now that we look at just the data for over 30 days, the average went from approximately 33 days to 49 days for the entire duration of these timelines. So now that we're here, we can go back in and look further into our time interval and break it down by, which department these problems or areas are being identified, and why is it taking so long. So like you can see here, it's taking 41% of these over 30 days is from the Community Life Improvement Department, 30% from the Streets Department, 21% from Licenses and Inspections, 11% over 30 days are from Parks and Recreation Department. We could even go further and break it down into the problem or the issue that was reported. We can see that commercial, trash on the curb, these are things that 11% of these timelines here are over 30 days, and these are the issues that are presenting these timelines for us. We can see that the average changes for these different days, and for each of these different problems, we can begin to break down and apply a filter. Maybe we just want to look at streetlights that were out. These are the problems that are only streetlights, and you can see we now have 3 filters: dimensional search, time interval. Now that I've uncovered some of those underlying issues, I can begin to break down and further look into some of these timelines related to the streetlight being out, and finding out more information about why these specific timelines are lasting over 30 days. So I'll go in and I can clear my filters here, just delete them, remove them, close it out, and begin to do some other searches. I'd like to go in and query some things and find out what we identified prior was that there's rework. So in that previous step, I found out that it's not the first work completed, but the second. So now I want to find out when work is being completed 2 or more times and where that's happening, and perhaps identify why that may be an issue. So I'm going to look and find out when work is completed, and I can search where it's happening more than 2 times. And all these are occurrences where work is happening more than 2 times. Begin to look and see what's going on, and work's completed and an inspector was assigned, but it was disapproved, so work to fix was scheduled again. So these are some issues that work needs to be completed twice because the work that was performed was not up to par with the inspection. So I can go in, I'll perform the time interval search again, and we already have our search from prior. It looks like it's reset itself. We'll go back to searching it for over 30 days. Apply that filter. As you can see, we'll now look at about 36% of the data. Now we'll query that search again where work is completed more than 2 times. We further drill down and break down the data where we're only looking at about 13%. We can see our average here is now 54 days from start to finish when the case is closed. And even here we can further break this down, look at time gaps. What's the average? There's 3 days of a time gap. These are things that are occurring within these timelines specific to issues over 30 days for work to be completed, and where work is being completed twice. And this is a great way to drill down and further evaluate the underlying issues within the data. So as you can see, we can perform some pretty complex queries and searches and drill down and find out where all these issues are within the data. I'll bring you back to another query later, but for now, I'll undo these filters and look into actually process mapping and process schema. We can go in here. I have some prepared, but we'll just go and we'll start a new one so I can show you how easy it is to find out how your process is flowing. We go in here, select default milestones, and generate a default schema. This is going to visually map the most common path for the process, and we can see by first allowing the software to take what it believes to be the most important, the default milestones. What's happening here is that TimelinePI is using advanced statistical analysis and specifically choosing which steps are most reliably and commonly occurring in the same place in the process. But this is rather boring. This is pretty straightforward. It's how you'd expect it. It's reported, open, departments assigned, inspector, issues either scheduled, issue found, work inspection, etc. These are things, but I want to go back and I want to find out more, and I want to include some work completed, work started, case closed, citation issued, other things that I want to evaluate and begin to look at as milestones that I'm looking to analyze and milestones that are important to me. So I want to go further and assign some of these things, and I'll generate that. And then I begin to see that this really can break down, and you can drag and drop and begin to see how these are working. And I can even, if I want to go further, I can just go back and add more, look at some of these other ones and bring them all in. Why not bring everything in? We can look at all of it. So we have this schema, and we begin to see, and it's just so easy to drag and drop and begin to see how this is really flowing. So if an issue is found or an issue is unfounded, where these processes are flowing and what's going on. We can drag these over here and quickly move them about to see how these things are functioning and working. It's pretty easy and simple to use. We can drag and drop, really build a pretty interface that is good, easy to understand, and can quickly analyze what we're doing here and see how these things are working. Now the cool thing is, if I save this, I can save it and begin to look at not only the process in it by itself, but I begin to see how many timelines are actually going through these. So how these things are occurring at what step. I can begin to look at the time length between the transitions, how long it's taking, the occurrences, the location of certain milestones. But all of this is a really great way to find out just exactly how your process works and begin to build a process analysis and building a schema that goes back and can see this. And I have this other one here that I've kind of straightened out and made a little bit prettier that is easy to see and understand. Same thing, it has all of the steps in this process here. It's just a little bit easier to see, and it's broken down, and you can set these rules and begin to see how things, and once it's saved, it can be a monitoring tool. So you can come back, load new data, you can monitor how new data functions and flows through here. So another cool thing, I'd like to go in here, edit this schema, remove when citation is issued. It's pretty much like a fine or something of that sort, and I'll save it again, and I want to look up the likelihood of when that event may occur. So this citation being issued, I can find out exactly when it's most likely to be issued. So whether that's right here, 56%, it's likely to be right after issues found and work to fix is scheduled. 7% up here, right before work is completed, and then 38% is where citations are issued right before the case is closed. So this is a really great tool that can begin to really drill down and find out more information and run queries and see where events are likely to happen if we don't know when they're occurring. So now that I begin to understand how my process works and what events are happening when and where, I've seen the path, I've seen how it functions, and I've developed a process schema that explains to me how the process is flowing and where events are most likely to occur. I'd like to perform another query for you, and this is something that I kind of thought of on my own, that maybe an issue, and is there any time where we're spending resources where I saw an event where the issue is found, or the issue, what about when it's unfounded? So when that happens, I can see here that there's stuff that's going on. It looks like work started after an issue was unfounded. I mean, this is really glaring. Like I said earlier, we could look at these timelines and begin to see where things are happening. And this says that the issue was unfounded, and there was stuff that was completed after that. If it was unfounded, I'd expect that it would just be closed because it's unfounded. So what I want to do is drill down on another query for you and look at it. So we have our earlier query. I'm just going to reset that. And this is maybe a little bit more complex than the earlier one, but I want to look and see where, an issue was unfounded, but then other things had occurred after it. And I'm going to put this in reference to anything that has to do with work. So whether work was started, work to fix was scheduled, a work inspector was assigned or scheduled, work inspection approved or disapproved, and work completed. So anything that has to do with work after an issue was unfounded. I'm going to add those 7 events. And this is going to be just a query, and I could even look at certain problems, look at departments. So I can add, whether it's that street light that we were looking at, or the sanitation department, the streets department. I can drill down on certain dates. But I'm just going to do a simple search here to find out issues that were unfounded and then had work that was completed, or any type of work-related event occurred after that. I quickly perform that search, and I see 12.33% of my timelines actually have an issue unfounded, but then have work that's occurring later. Some of these look like they may have been found later. So you can really start to drill down and find things that are going on. So I've just demonstrated there for you is just how important this search or query tool is. Traditional business intelligence searches look for objects by using only their attributes, those dimensions we talked about earlier. But what if we need to find things by their history? Like I just showed you, it's that scenario where how often does this certain thing happen? When we have work that's completed after an issue is unfounded. Seems like probably shouldn't happen, but by using only the BI search tools, we'd have a very difficult, if not impossible, time answering that question. As you can see, it only took a few minutes to really drill down, begin to see those underlying issues, and perform a quick search and query that was able to show us nearly 13% of our timelines that had that issue. It was done extremely quickly and easily. And the beauty of it all is that these queries don't need to be trivial either. Of course, we can go back in and really drill down further, specify a variety of other options, the time constraints, the number of repetitions, specific values for those attributes. But the one thing is that I just dare you to answer this type of question using any other tool. In my experience, it would take pages and pages of SQL code to even begin surfacing the data like this. This TimelinePI tool has the ability to go off and explore and test the hypothesis. But these aspects of these queries that you can set them up to trigger alerts. We don't need to just babysit this data all day long. We can trigger alerts, fire off emails when conditions are met, making people aware of the case that's occurring. It's a whole nother level of accountability built into the process. This tool is really critical for any business that wants to drill down and analyze their processes more, learn about how their process flows. And as you can see, with just the simple searches that we did, we can find out where there's issues. We can just find out exactly how our process functions and flows. The tool is just truly amazing with everything that it does. I'll show you one more thing where we're looking at this 13% of where issues are unfound but work's completed. I can go in and I can find out what department that happened in. You can see 41% of it is in the community life improvement, 31% in the streets department. All of these things so quick. Just really break it down and begin to see when these things are happening. I can break it down by problem and look at maybe only, like we did earlier, only look at the timelines with street lights out. I apply the filter. Now we're only looking at 1.23% of our timelines, or 357 timelines out of 28,000 plus. But this is just a really quick tool to use. We can start seeing some anomalies in the data, some outliers, some things that are oddly occurring. It is truly just an amazing tool. Thanks for stopping by. This concludes the demonstration by Ryan at TimelinePI. To learn more about TimelinePI and the tool, visit us on the web at TimelinePI.com. You can sign up for a free trial and begin to use all of the features and even see the project used in this demo at online.timelinepi.com. If you want more information, you can check out our other demonstration videos, or to talk to someone directly, you can email us at info@timelinepi.com.